What up nerds, your boy Hansi here, and if there's something I've always wanted to make, it's a hidden door. Today we're doing that, but we're making it entirely automatic and electronically operated. This will be a two-part project and we'll start with the hidden door mechanism today. No need to delay, so let's just get started. To start off this project, Martina helped me with some sketches to better visualize the mechanism I have in mind. The door has to move along two axes, along a track that takes it to the side when somebody wants to enter, but also outwards to make a seamless border with the wall. I'm beginning by building a sled for the door. It'll roll on some 16mm copper tubing, and the axle of the cart will be a 8mm threaded rod. Some grooved pulley guides attached to it will act as wheels. The threaded rod needs a straight hole through the woodboard. I had to first pre-drill a hole with my drill press and finish the hole with a handheld drill and a longer drill bit. If I had a larger drill press that could fit the long bit, I'd be doing it all there. Because if the hole is not straight, the cart will be wobbly and pretty much unusable with the precision I need in this build. With the holes placed, I put the wheels next to the base of the cart. Then I could mark off where I had to cut the threaded rod to get it through the wheels while still leaving some space for the nut. I used my metal bandsaw to cut the threaded rod, but it can easily be cut with a regular hacksaw. With two rods cut to the proper size, it's time to assemble the cart and see if this will work. I added a spacer and a nut, then put on the wheel, put on a lock nut at the end, and then tightened everything. I did the same thing on all other sides, and finally made sure everything moved smoothly. To check that the friction was as low as I hoped and that it wasn't wobbly at all, I put the copper tubing on my desk and gave it a test run, and I was pretty satisfied with the low friction and the steadiness. We have finished the base of the cart and we can now continue building the railing mechanism. This is the mechanism that will push the door outwards to line it up with the wall. For this purpose I use two 25kg drawer slides. The benefit of using drawer slides is that they are easily obtainable and they have very little friction, which makes it easy for the motor to move it. I marked the length of the slides on a 2x2. Being accurate at this stage removes some headache later on, because if they are not measured right, the door may end up a little bit crooked. Once I had cut the 2x2 in two equal lengths, I put the slides on top of each piece to make sure they were cut to the correct length. Before fastening these slider supports, we need to drill a hole through both of them. The hole needs to be at the center of both and go through from the side when fastened to the cart. This is because the holes will be used to support a 10mm threaded rod that will be driven by a motor. This threaded rod is what will pull the cart along the rails, but we'll get back to that later. For now, all we need to do is to prepare the holes and add a T-nut to one of them. Again, to get the hole as straight as possible, I pre-drilled the hole using my drill press. But it's not large enough to fit the largest bit, so I used a larger drill bit on a manual drill to get through. Once I was through both of them, I used a thicker drill bit on one of the holes, and this is because this is the piece that will not include a T-nut, but the threaded rod still has to go through it, so the larger hole is to minimize the friction when the threaded rod passes it. I was using a hammer to knock the T-nut in position, but in my earliest test of the mechanism, the T-nut managed to vibrate its way loose in a very short amount of time. That is why I'm drilling in 4 small screws right next to the edge of the T-nut to better lock it in place and prevent it from pushing its way out after being in use for a while. Now I mark the position that I will place the 2x2s on, preferably as close to the wheels as possible without preventing them from turning, because the space between the 2x2s also determines the maximum width of the door. Before fastening them, it's important that the holes through the middle are perfectly aligned. If they're not, the threaded rod will get tension and wear out the threads of the T-nut in a short amount of time. When I was sure that the 2x2s were aligned, I drilled them in place using some long wood screws. Pre-drilling the holes is always a good idea to prevent the wood from cracking. When both of them were fastened, I put the drawer slides on top and used the small screws that came with the slides to attach them to the 2x2s. Then I cut another set of equally long 2x2s. These are supposed to go on top of the slides and will serve as the construction base of the door. To attach them to the drawer slides, I had to flip the entire contraption upside down and pull out the drawers. I fastened them using the same screws that came with the slides. It's important that these 2x2s are perfectly parallel to the drawer slides, else we'll have the problem with a crooked door again. I measured the distance between the boards attached to the slides and cut a 2x2 to fit in the gap. I fastened it using some longer wood screws. This is the front of the door, and the face of the door will be built on top of it. After drilling in the screws, I made sure that it still slid without a lot of friction. If the board was too short or too long, I could have offset the course of the slides so that they were no longer parallel, and hence get a massive increase in friction. Luckily this didn't happen and everything seemed to move fine. I used a flat connector plate to prevent the door from moving too far back, and it will also help making the door stand up straight later on. After the connector plates were secured, I began the work on hooking up the linear actuator. The linear actuator is responsible for moving the door outwards, so this has to be independently fastened to the base of the cart in one end, and then to the sliding part of the door in the other end. By holding a piece of wood board next to it, I marked its profile and cut it out with a jigsaw. Now this is just a support structure to help me fasten the actuator, and it will not be a part of the final construction. I drilled a hole in a piece of 2x2 that matches the size of the mounting point on the cart side of the actuator. After double checking that it was placed at the correct height, I measured the middle of the hole and traced the line across all sides of the 2x2. Then I drilled a hole through one of the sides. This is to be able to stick a long screw, or in my case some threaded rod, through the mounting hole of the actuator, so that I can fasten it to the 2x2. Using some leftover 1x2 and a piece of 2x2, I created a support enclosure for the door end of the linear actuator, so that I could pull the threaded rod through the pieces of wood for some extra sturdiness. To fasten the linear actuator to the two support constructions, I used some metal spacers and for simplicity some wing nuts. Finally, the 2x2 that holds the actuator to the base of the cart was attached with some steel angle brackets. Now, when I attach a 12-volt power source to the actuator, the door moves outwards. If the positive and negatives are reversed, the door moves back into position. Well, I say door, but this isn't really a door yet. But we'll get to that soon enough. So the sled itself is pretty much done. What we have to do next is to build a door on top of it. But before we can do that, we have to clean out the wine cellar so that we have some room to work in. This is our wine cellar, and it could need some improvements. By building a wall, I will be splitting the room in two parts, and the hidden door will be placed on that wall. But first I have to clean out everything. It's old and moldy, so I also had to get rid of some mold. I had to improve the ventilation to prevent it from coming back, and I had to put barges on the concrete to prepare it for a new wall. While I am putting on the barges, I just want to quickly remind you that we're on Instagram, posting all sorts of behind the scenes content. Follow us if you want, and we'll keep you in the loop of what's going on. The purpose of the wall is mainly aesthetical. I decided to go for 2x2s to build the wall because it is what I had lying around. It might not be the best material to build a wall from, but I think it's going to be fine, especially since the wall is so small. Right now I'll just be building the frame for the wall, because I need it as a reference for where the door should stand. When the frame for the wall was done, I carried the copper tubing and the cart into the room off camera. Then I measured the distance from the door base of the cart to the ceiling. I deliberately cut pieces that reached all the way to the ceiling, and I will cut them later, but that gives me the freedom to decide the height of the door after seeing how sturdy it is. To strengthen the construction, Martina helped me hold some shorter lengths of 2x2 up to the door frame. This way I could mark the angles I needed to cut to create the support studs. With the support studs in place, the door was surprisingly steady and not wobbly at all. So when I decided the height of the door, I added a crossbar to the top and removed the excess material above it, and this basically finishes the door frame. Now we can see that when I attach the 12-volt power source, the door moves outwards and inwards depending on the direction of the current. To prevent the door from tipping forward when extended, I have to hold it back manually, so I'll be looking into adding some counterweights to that. What's left of the mechanism is adding the motor to drag it along the rails, and create some framework to hold the rails in place, which we'll do in the next video. So today we built a sled, cleaned out the wine cellar and tested one axis of motion. In the next part we'll finish the rail system, build the wall that the door will be hidden in, and see how well it performs. Meanwhile, stay in touch on Instagram and I'll see you when we wrap this project up.